All right, we're going to do a fast review of a few slides so that we start on a section. All right, we cannot quantify E, right? It's nothing that you could possibly quantify because virtually all complex systems, all complex systems, all systems basically, are connected to all other systems across space-time. And so therefore you really can't even measure the emergent information as a local observer. You'd have to be a kind of global observer across all of space-time to do that. And E at any strata possesses a so it's not computable in the first place in a finite universe, if you had a universal, Turing machine. Secondly, you'd have to be a non-local observer at the global scale, even if it were computable, even if it were not an NP problem. And due to the fact that any local system is part of a transspatial and transtemporal network of other complex systems, and two, because E just can't be conserved, even in principle. So you don't know how far it's reached toward infinity. It's simply untenable to arbitrarily select a cutoff for measuring the E associated with the local system. And so, what can we do with E analytically in order to study it and exploit it for technology? The first step in thinking about the physics of exploiting the E of emergence theory is to combine a few older thought categories, such specifically Shannon and Boltzmann's entropy information theory and generalized language and code theory. And so one common theme is the idea in codes, or Shannon or Boltzmann's entropy, or quantum mechanics, is the notion of noise, the notion of meaning, and the notion of information. So obviously in classic thermodynamics, we have high noise and low meaning with high entropy due to collisions driving an explosion of parallel vector classes, which simply disorganize all I that would have been in the system toward little I. And in quantum mechanics, when a system becomes disorderly enough, its non-local quantum correlations, which are strata of E, can drop such that I becomes approximately little I. So, however, the only time in quantum mechanics when I would equal little I would be in some volume of vacuum space near 0 Kelvin, where the ultimate disorder of the Dirac sea of virtual bosons and fermions expresses a form of Planck scale noise. So in our approach, that corresponds to local AB equals P solutions with one minimally small rank in the inflation-deflation spectrum. Again, we'll get to this later, but it's about distance, right? Because if you have an extremely high frequency of collisions and you have a discrete space-time view where every particle coordinate change must be in integer multiples of the Planck length, right? Your collision frequency is high over space-time, so therefore the average quantity of the Planck length per discrete coordinate change tends toward the irreducible unit at the Planck length. And so that corresponds to cut and projection operations with larger cut windows, and that corresponds to a family of AB equals P solutions, which are a finite set of solutions at that scale. And the scale happens to be, in our object, the golden ratio power series. Except in E8, it's not the golden ratio power series. And highly disordered sets, that is the rest of the sentence here. In our approach, what I said before, the idea of noise, would correspond to a low value in the spectrum of thickness, window thicknesses of projection operators in AB equals P solutions. and order. Your ordering quality must be poor, noisy, in order for the cut window in some spectrum of the solutions to be a very small cut window. As order increases, the cut window thickness, and therefore a new scale of solutions changes. In other words, the probability amplitudes for each P solution on each shell that are defined by discrete translations of the cut window relative to the empire window boundary are equal. So if you had 5 possible translations, there would be an equal probability for each. So you'd have no peaks. You'd have no energy landscape, so to speak. Well, you would have a flat energy landscape. Anyway, noise such that I equals little I. So in Shannon's entropy, noise in codes degrades the information content of the signals. And in general code and language theory, just generalized from computer codes to spoken languages, noise can include poor use of legal syntax. So no breaking of rules, right? No defects per se, but poor use in the form of redundancy, a kind of a kind of anti-principle of least action, right, in a code. And, or noise can mean illegal syntax use, such as some notion of defects in a code where symbolism ceases to serve its purpose progressively, as far as its purpose being to convey meaning, including emergent meaning, above the conserved sum of the meaning of each symbol or action in your base information. So in all cases, we have an inverse relationship between noise and emergent meaning. So one rigorous physical thing that we can say about E is that it degrades with defects or misuse of the order of the legal building blocks. We can say, but can we say anything helpful about different magnitudes of E, even though we cannot quantify E? Well, we can realize that the magnitude of E correlates to the weighted average and quantity of complex systems that would be connected to something that you're trying to measure a quantity of E or connectedness with. And the weighting requires you to put a higher value with increasing strata rank on different strata, right? And so I don't know how to put a value conceptually on all of the strata of E, but maybe we could figure something out, a form we might be able to figure out somehow. For example, if system A at strata 2 of some fixed local complexity is connected only to 2 systems at strata 3 at some fixed complexity that are themselves not connected to any other systems, then we can say that system A has a lower magnitude of E than an identical system A at strata 2 connected to 2 systems of otherwise similar complexity at strata 3, right? Just by simply knowing in this category theory-based idea where we only know that each strata is of a higher magnitude of E, and we understand why the strata are ordered, just as we understand that words are at strata 2 because they are composed of strata 1, and so on. So this is, of course, as I said, non-computable, but we can still discuss the form in order to have some better insight into what our formalism will evolve into. But it tells us a principle that's instructive, which is systems can have very different levels of connectivity to other systems and to various strata levels of information. So take, for example, the complex system of a person, a whole person, very, very high up the strata hierarchy. And that person's very ideas and words can change the course of history profoundly on a global scale. So they have causal, self-organizing, neg-entropic power over an enormous sort of butterfly cascade of change that someone who lives in a cave all their life and doesn't talk to anyone may not have. So an enormous class of examples of physical systems are like this, all physical systems specifically. But I can think of none better than the one I brought up yesterday, which is DNA. And that encodes the entire history of life on Earth, lasting for about a third the age of the universe. And it gives instructions for genetically transferred tendencies, such as artistic creativity, in addition to protein folding algorithms and simpler lines of code. Another fun example is a set of highly ordered atoms expressing a man-made line of binary code in a computer that triggers a speaker to play a frequency that self-organizes disorderly sand into symmetric mosaic patterns based on what that digital information was. So even though we cannot fully quantify E, how can we provoke it to emerge in some physical system for the purpose of creating a device? Well, easy, in my opinion. Reduce the spatiotemporal freedom of atoms toward the non-zero limit, where the near-neighbor distances allow for the most efficient code of oscillators, the two-letter class. You can start by building a quantum computer using this method, or driving low-energy nuclear reactions with this same principle. And that is what we are going to do. But why? Why does that make sense? Remember, nature uses the QSN, according to all those long-winded arguments yesterday, because it is the maximally efficient network of two-letter codes. And because she seems very worried about efficiency, and so follows the principle of efficient language. We can do a pretty good job nowadays organizing atoms. So this is where we can simulate what nature has already realized at the Planck scale in the form of the QSN quantum field theory. Schrödinger was onto these ideas before I was. In the years before his 1944 book, What is Life, where he introduced the term neg-entropy, or negative entropy, he was thinking about how it is that the molecule, which encodes genes, could pack so much self-organizing information into a small volume. Remember, the molecule itself wasn't even identified until 1953, but they knew it existed for some time before that. So Schrödinger was thinking, this information can't be encoded into a crystalline molecule because that's too orderly and simple. And it can't be encoded into an amorphous cluster of atoms because that would not be able to encode anything at all. So pause for one moment. There are three and only three ways anything can be arranged over time and space: periodic, aperiodic, or disorderly. And physically, of course, every meaningfully sized system is some ratio of all three of these things. In the 1970s, Paul Steinhardt coined the term quasi crystal in a paper where he and his co-author made a very bold claim. The forbidden symmetry can exist in scalable atomic motifs. Linus Pauling at Caltech, the only man to ever win 2 Nobel Prizes, was one of the most vociferous opponents of this idea because the five-fold symmetry is forbidden by classic physics. If you follow classic physics logically all the way through, you start to understand why it was the foundational axiom of crystallography. And so when Danny Shechtman claimed in a paper to have seen the forbidden symmetry in the electron microscope he was looking through. Linus Pauling got the most airtime in the world as the community responded to this apparently ridiculous claim of the forbidden symmetry. So back to Schrödinger. So Irwin, which I think is a very nice name, said in his 1944 book, What is Life, something to the extent of this. A crystal is too simple to encode, and a disorderly material can't encode. So genes must be encoded in an aperiodic crystal. And its vast magnitude of instructions encoded in it that tell other mass energy how to self-organize acts as negative entropy. So I'm paraphrasing, by the way, what he wrote from the book for compactness here. But let me be clear about one thing. He exactly used the term quasi-aperiodic crystal. He deduced a core idea of the code theoretic axiom by recognizing that if a natural physical code can be made of atoms, it must be quasi-crystalline, where a broader definition of that term can mean anything with H2, H3, or H4 symmetry, both narrower and broader, right? Because there are quasi-crystals by cut and projection that do not have those symmetries. All right, so DNA has H2 symmetry and is built of the golden ratio in several ways. It has 5-fold rotational symmetry in each of its 2 helices. Each helix is rotated from the other by a golden ratio-based angle, and each helix is offset from the other, this way, by a ratio that is 2 successive Fibonacci numbers, the integer series that terminates at the golden ratio and the series which approaches its limit faster than any other. So nature uses DNA with its golden ratio construction because it's efficient for coding. And in the few cases where nature uses RNA, it's the same thing, right? DNA is essentially 2 RNAs. So the efficiency comes from the reduction to 2 letters. Under the 3D code of 4 molecular letters, DNA can be decomposed into a string of one-dimensional atomic chains where the fundamental lengths are 1 and 1 over the golden ratio. So nature uses the golden ratio at the Planck scale in the QSN for the same reason. So nature figured out that she must use DNA to create this strange neg-entropy that Schrödinger was keying into 50 years ago. And nature, for the same reason, the principle of efficient language, uses the golden ratio in H3 symmetry in a topological quantum field theory that we're trying to discover. So if you are a technologist and would like to exploit code theoretic thermodynamics, do what nature did with DNA. Arrange your atoms into the forbidden symmetry. Maximally potentiate entanglement entropy by organizing atoms into scalable arrays of atoms possessing H3 quasi-crystalline symmetry, and you will get anomalous physics, as reported in hundreds of papers. Maximally potentiate atomic tunneling frequency at angstrom scale distances, which reduce your energy landscape into a network of one-dimensional energy wells with 2 fundamental near-neighbor distances as 1 and 1 over the golden ratio. And work in phase space by exploring electromagnetism and ultrasound frequencies that are temporal or beat-based quasi-crystals. We have published a paper on how quantum mechanic tunneling probability amplitudes exponentially increase with such beat quasi crystals in our paper Catalytic Mechanism of Low Energy Nuclear Reactions in Quasi Crystals based on localized anharmonic vibrations and phasons. Now we're going to dip our toes further into emergence theory physics. Under the wavy energy landscape of our world is a dynamic moire pattern of Fibonacci chains. So these are empires. Empires are general. So an empire is not just an empire relative to vertex types. An empire is just a concept that says, if, according to the legal tiling rules, you have this constellation of objects, then the question is, what are the constellations of other objects which must be forced to exist, and what is the second constellation of objects forced not to exist, and thirdly, what is the constellation of objects which may or may not exist at such and such coordinates. So we want to reduce to Fibonacci chains because we're going to reduce ultimately to a tensor network formalism where we can represent each Fibonacci chain and talk about eigenvalues on a network of Fibonacci chains as a three-dimensional quasi-crystal in the QSN possibility space. And we're going to think about the interaction of all of these matrices of one-dimensional Fibonacci chains, which are dynamical, as a sort of sum of waves space, which becomes our discretized quantum field. The scaffolding of these patterns that you're seeing, or the scaffolding of patterns in any phazon animation, which this isn't a phazon animation, are the empire waves. The empire waves are key to everything, and the cut window and the empire window are the defining quality of language syntax in this formalism. So we can understand the peaks and troughs of our energy landscape as convergence zones of empire waves, like convergence zones defining a moire pattern. And the sum of empire waves is called the empire wave field. So how does a radial thing, like an empire, create waves? We need two or more frames over the time domain, or two or more empires in order to see the idea of waves. So this is not over time. This is simply a superposition, in some sense, of two points that have radial lines coming out. And you begin to see in frozen form the general wave form emerging in frozen time. The right image can symbolize the relationship of two different empires in one frame of the QSN. You know, you can kind of use your imagination to go to a three-dimensional case in the QSN where you see three-dimensional waveform even in one frozen frame. And so waveform emerges as the relationships of these two radial patterns, where we can think of the convergence points as peaks and troughs in an energy landscape. And when we go to the time dimension with two or more ordered frames in ordered sets, where each frame, again, is a code-legal deflation of your scale 1 possibility space. Then we can get wave propagation of our peaks and troughs in the energy landscape. Okay, I can't even control the mouse. But, okay, so in the other image, we saw this frozen waveform emerge. So as you rotate one of these, what happens is the wave fronts propagate. And the empires rotate in the QSN, whether fermions or bosons. So let's generalize fermions and bosons as particles that have knots, okay? They do Hamiltonian or Eulerian circuits as ordered sets. And what happens is, if you model that as an electron at rest without it propagating, it'll go through a Hamiltonian circuit in n frames where the object itself is rotating in a stepwise spherical manner such that the empire waves, these radial things themselves, are rotating in a stepwise pattern. And then, because it's a knot, it's massive. So here we have a fermion. And there are no electrons at rest in the universe, not likely. And so they're always propagating along some helical path with a Planck scale pitch. And that naturally creates an empire wave that is almost too difficult to visualize. But it's complex. And it looks, in my visualizations, similar to the projection of a 3-sphere to R3. So,
a clear comment. You said earlier about a discrete field, the wave, the empire wave, but it's a little more tricky because we understand that this is more the probability amplitudes and transition.
That's what I'm getting
amplitudes.
To next.
So at this level, it's not
I'm giving you
clear that.
So far, I'm giving you classic analogy.
If it's the wave function, it's not clear that we need a discretization of the classical field, because maybe this discrete wave, empire wave, it's about the physical helix amplitudes, like for gravity. But the classical gravitational field that we see is emergent, so maybe there are not a direct link to a discretization of the usual gravitational field.
Yes.
But it's more emergence of like Lorentz symmetry.
Right.
So
For
yeah.
electromagnetic quantum energy landscapes, I'm going to put forth a very clear idea. So just give me a few frames to do that. So this, in my animation at my computer, had these cool wave fronts just going blue, 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 just propagating.
I can see some of them there at the middle. I can see them at the center.
Yeah.
Starting to form.
Yeah, but it's really cool. So anyway, what exactly are the energy peaks and troughs of this energy landscape that we speak of? This is a nice way to symbolize the idea of repulsion, attraction, and null interaction. So here, information theoretically, we don't save any letters. To express the meaning of cat and pot, we're using 6 actions, 6 symbolic actions, 6 of our irreducible symbolic elements. But in this case, if we tried to do this, we would not, it would be a kind of repulsion because we have a conflict here. so the system can't do that. But here, the system can do that. If the empire field requires an A here for this particle and an A here for this particle at some identical x, y, z, t for each of the two, then there is an information theoretic savings in the code, in the quasi crystal code, which physically results in one frame less being used. And remember, the frame is time. So if you just take out a unit of time in a video, right, we just take out a frame. What happens? We have a dot moving blip, 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 blip. And if we take one of those frames out, it results, from your vantage point, in the blip moving faster, like accelerating. And then in this case, where there's no interaction, no conflict of a right-handed tetrahedra conflicting where another empire wave needs a left-handed tetrahedra at x, y, z, t, then in this case, there's simply no interaction between the two, no acceleration. So an on-right trit needed at x, y, z, t for the propagation pattern in the empire wave of particle A in the QSN will cause a conflict or a trit cost resulting in repulsion. In other words, the avoidance. The system avoids that. System doesn't like crashing. Okay, so it'll avoid that. If a different particle field B requires an on left at that same x, y, z, t. And so then we would have a trit cost equals repulsion. But if both empire waves require the same trit state at x, y, z, t, attraction occurs. And if the empires have neither trit savings nor cost, there is null interaction. So that's the principle. That's the raw concept of forces. So accordingly, our energy landscape is a landscape of relationships for particles where the probabilities for each particle at some time too are relative to its relationship with this trit-based quantum field theory, which itself is built of the empire wave concept. So, what defines probability amplitudes in quantum mechanics? The quantum energy landscape, which also encodes or allows one to recover the classic energy landscape, right? In other words, in our formalism, trit cost, savings, and null interaction will define the quantum energy landscape of our quantum field theory, and therefore will define the probability amplitudes for any time too. And it is the sum of dynamic empire waves, which is the empire wave quantum field, which defines our discrete quantum field theory energy landscape again. So far I'm going to go further, but does this so far make sense in some general way? All right.
Just a comment. So with quantum field theory, one has the concept of a fiber bundle.
Mm-hmm.
So here there would need to be something analogous to it,
right?
A discretized fiber bundle that
right.
should be seen also by the empire waves. So
that's right. So good point, Mike. So me and Marcelo talk a lot about this, which is we first started, and Fong was interested in this too. We were talking about casting out an infinity of fibers such that you only take the fibers on, for example, a two-sphere, okay, which are coincident with the vertices of, for example, an icosahedron inscribed within that two-sphere, right? So now you've just cast out an infinity. You have a very small set of 30 fibers. Next, you discretize the infinite set of points, or you cast out an infinity of points on each of your one spheres, leaving only the points coincident with the vertices of the inscribed icosahedron. Now, what do you have? Now you have 30, you have a set of 30 polygons, regular polygons. And if you try to take walks around this object, you'll be working in a sort of Dirichlet integer kind of set of walks. Whereas if you did the same thing up in the Gossett polytope, you would be using integer walks.
So you mentioned the discretized sphere.
Yeah.
So in that case, one can perhaps look at that as a discretized SU2 transformation.
Right.
That'd be some kind of
Yeah.
SU2 gauge theory.
Yeah, it seems all this SU2, and these hope fiber theories, it seems to me all translatable to a discretization of those formalisms into essentially Platonic and hyper Platonic geometry, where you're dealing at the end of the day with angles and polygons and or straight lines that run through the network, which are one-dimensional quasi-crystals.
But I was think that you can say it's a discretization of SU2, but you can think that you could use the word quantization.
Yes.
And then you have a bonus like SU2 about rotation, so you have a quantization of rotation that in some level you interpret that is a discretization of some field.
Yes.
But you have a bonus, it's a discretization where you can think about the classical field like a classical limit.
Yeah, you mentioned the complex projective line, CP1. So the SU2 acts on the CP1 as isometries. So really, one just discretizes the complex projective spaces, which will probably be seen here, and naturally, the analog of the isometry group will be the gauge symmetry.
Let's go. Okay, so, all right, so probability amplitudes. Now we're going to try to get a little bit more serious here. So probability amplitudes in this framework are defined as the relationship between a particle's empire field. It's never really exactly the particle, right? Particles don't interact, their fields interact. So it's the empire wave field of the particle, and which is only an object which exists over n frames, where n is greater than 1. And the sum of all other empire fields in the universe, but with exponentially more influence between particles related by distance, where near distance empire fields generally, and then there's another case where distance doesn't matter, and that's a rare case of special alignments in phase space and geometric orientation space between two quasi-particles that can be separated at any distance in time or space. So then you essentially, like if I get me and Dugan together in a kind of Bose-Einstein condensate in our formalism, what that means is he and I enter into a sort of resonance, where our word resonance is relating to when he changes position in the ordered frame of sets, because he doesn't have to change positions every Planck moment, that is every sequential shell, which the shells should be rolling along at what we call 10 to the 44 frames per second, but we geometricize that. So anyway, Dugan and I, we're in some close proximity where it's easy for us to enter into force relationships that, due to energetic conservation, cause us to fall into a sort of discretized version of a Bose-Einstein condensate. So we're entangled. And now we are moved apart in time and or space. And we will, of course, from experiments, we know that those two particles that were formerly in a Bose-Einstein condensate will remain entangled non-locally. But what does that mean in our formalism of empire fields? Well, perhaps it can mean that as we go out, according to some principle in the C plus P space that defines our probability amplitudes, which were always going to be defined by the classic and quantum energy landscapes, now we're separated, and according to the PEL, there's no reason to take us out of the information-saving synergy of that correlated relationship. Something would have to separate us. Some kind of force would have to specifically break us out of that entangled relationship. But if it doesn't, then no matter how far he and I separate, we're still connected. Because remember this idea of an empire wave universal field, right? This universal quantum field of empire waves. You have to understand that the empires run through n frames. They run through time, and they run throughout space. Again, just repeating from yesterday, such that every microscopic but sufficiently large volume of the QSN in your body dynamically is part of this sum of waves space of all of the empire waves, of everything across time. So when he and I were in the Bose-Einstein condensate, we mathematically entered into a very special set of shared solutions in the AB equals P space up in the E8 tensor network formalism. And so therefore our probability amplitudes will remain within this restricted set no matter that we are separated in space-time, because the empires are trans-spatiotemporal. But how does this relate to, one, the action horizon idea, and two, the space of AB equals P tensor network solutions? The first principles of syntactical freedom on the QSN physical universe was mathematically discovered by Fong, as we know. And this is a shell in the action horizon model at Rn, right? This is a shell. You can see it's a very small shell, so you should assume this would be a shell at some very low shell number, a very few Planck moments after the Big Bang at the origin. So for each Planck time, LT, now replaced by length by us, because now time is replaced by the shell action horizon. So now you can roughly equate the old LT with the old LP, and then you can convert the old LP to the new unit length of the quasi-crystalline spin network, or the sum of the two fundamental unit lengths as 1 and 1 over golden ratio. In the form, right, this time, in the form of shells, S, at some radius, R, from the origin of the Big Bang. There is a set of possible shells, okay, that it could have been, right, some set of S. With each one of these, 1, 2, 3, to infinity, or not to infinity, to some finite number, having a different probability amplitude in the space of cut plus projection solutions isomorphic to the space of algebraic A, B equals P solutions. All right, so let's say that this is 1. It was chosen. And this, in pink, is 2. And it was not chosen. And that it's a very small space of AB equals P solutions, and the space only contains 2 in this case, right? Let's say it contains only 2. So here we have a sort of notion of a superposition or sum of the 2, and that's called a possibility space. So the idea of quasi-crystals is to act upon an invisible possibility space with your legal graph drawings. And each legal graph drawing should be understood as a deflation upon the possibility space as defined by the thickness of the cut window in the cut plus projection operators that act on E8, which are isomorphic to the AB equals P algebraic operations. So in this simple case of 2 possible shells at Rn, in the action horizon cosmological understanding of the QSN thinking, we know that each is equal to a cut and plus projection operator on E8. We also know that this has the algebraic solution in the AB equals P solution space. And we know that we have only 2 solutions in this space. Again, what is it that defines the probability amplitude for each of these 2 solutions, each of these 2 deflations, state selections on the QSN?
You use the word cosmology. For me, it's more, this model is more for like scattering amplitude, scattering process. Process that you can include gravity, but at a fundamental particle level, I don't see this for cosmology, but just
the interactions, well, the space-time will come from the interactions. So if you start with some root vectors.
Yeah, so local interaction.
I don't...
not cosmological interaction. Because it's talk about probability amplitude, so it's quantum cosmology then. So it's
if it's from
the earlier universe.
Let's say if you start with the 240 root vectors, I'm looking at it that way. If you start with the initial 240 and you pick a subset and you act on those.
Because the cosmology is much more complicated, right?
Marcel,
the Big Bang should create everything.
Guys,
so
hold on, because I don't want to go there, Mike, with those answers yet, because I want to identify terms.
Okay.
What is cosmology? How are you interpreting my use of the word cosmology? Because I'm only saying cosmology because I'm talking about the origin at the Big Bang, and I'm relating time for you to ordered sets of shells, and I'm relating that to radius from the origin. So all of those words, I thought it would be helpful to generally talk about cosmology as just a phrase, because I'm talking about the expansion of the universe. And a new way to think about what time is in this action horizon view. So that's where I mean cosmology. But when you're talking, you're pulling in gravity again. And I haven't gotten to a place in the presentation where I've explained yet my idea on how all attraction and repulsion, even gravity, is...
For gravity is okay, but for the cosmology, quantum cosmology, Big Bang, it's far away to be clear. It's not, don't make sense.
Okay. So I'll have to understand more about understanding your concern, but I don't. It sounds like it'll take me at least 5 minutes to understand your concern.
When I have my presentation on shells, I'll be talking about all these things, so we can resume this discussion then.
Okay. Yeah. Okay. All right. So we're following this idea where I'm connecting all these familiar phrases like possibility space. We're now all of us are getting more and more familiar with how deflation and inflation deeply relates to Fang's kind of first principles explanation of the syntactical freedom, where we can see that there is always a finite set of possible state selections and a finite set of possible cut window thicknesses that you can have when you're setting your possibility space at 1, right? Or at phi. Like when you set it in a discretized space view, you really can't go lower than that. You can only go higher than that. Anyway, so we'll just keep loosely following it and imagine the ideas in your mind slowly getting a little bit more connected every time we talk about this stuff. Now the energy, so we're trying to get to the probability amplitudes, okay? So the energy landscape of the spin network in 3D would define the probability amplitudes, right? Because I'm asking here, okay, again, so what defines the probability amplitude for each of these two solutions? Like, why aren't they 50-50? Or are they 50-50, right? Here we only have two, A, B equals P solutions, okay? Now, generally, physically, we should expect that they don't have the same solutions because we don't live in a universe that has a smooth quantum energy landscape, okay? So it's really trivial. The question is kind of hypothetical. It's implied, you know, because we've been talking about it. The energy, what defines the probability amplitudes is the energy landscape of the spin network in 3D, and it has to be dynamical. You cannot have an empire wave or an empire wave energy landscape with one frame. It is just like you can't have anything by taking your laser show principle and beaming it on one part of the two-sphere. And then that's it. You can start getting quasi-particle pattern when you have two or more of those selections of points that you can point to on a two-sphere, on a discretized two-sphere, right? Like an inscribed polyhedron. So the network defined over n frames as the empire wave quantum field, right? In other words, I'm saying that we already know trivially from quantum mechanics that the probability amplitudes are simply defined by the quantum energy landscape, okay? So then we're saying, all right, well, what is the quantum energy landscape in our formalism? And then we said, well, it is the sum of the quantum, it is the sum of the empire waves in some system you're measuring. That defines your dynamic energy landscape. And the sum of that can be formalized geometrically as a spin network where you practice your graph formalism of the spin network on a graph drawing, which is specifically the possibility space of the QSN. And the possibility space of the QSN, we work with trits instead of bits. We do not work with points. And we don't even really work with connections between points. We have the QSN, which we now understand a lot about why it's logical to be exactly as dense as it is, the latest QSN. That is your possibility space, and what you do is you turn tetrahedra in state selections on or off, where those must relate to E8 cut plus projection operators acting upon Else or Sloan, which then changes the slice selected and then changes Fong's compounding process to create a state selection on the QSN. Each of pink and yellow are state selections on the QSN, which each correspond to a different cut plus projection operator on E8, which each correspond to a different A times B equals P solution in the tensor network formalism. Okay, so now, okay, fine. So it's the energy landscape that defines our algebraic probability amplitudes in the tensor network. But how do we formally map a probability amplitude in the space of P solutions? How do we connect this geometric object as the spatial representation of a spin network, the QSN, to this algebraic tensor network of matrices? Of course, the tensor network creates algebraic relationships that define the interaction of subsets of the tensor network. In this case, interactions that create peaks in the spectrum of probability amplitudes. And now, hopefully, a picture is emerging where we can understand these peaks by mapping the tensor network to the energy landscape of trit cost, savings and null interaction. Nature likes to point her probabilities at the low energy locations in the quantum energy landscape. And that's because nature obeys the principle of efficient language. And at the irreducible code theoretic thinking, you can save a trit, just like when I write pot, right, and caught. I can save one of my 6 letters and do the whole thing with only 5 letters. And when you have a crossing of a 20 group right-handed here in some empire field for some particle at Cinziana's location, and there's another particle at Giovanna's location, and there's one 20 group required that must be on right to express that step in the 2 different empire waves, then there is a savings. And that savings results in a savings of a frame in the ordered set of radii that define the different shells, where each shell has some set of choices of other shells that it could have been. So what would nature do? Pick one of the set of A, B equals P solutions where there's a trit conflict, which generates a repulsion, or would nature follow the energetic path of least resistance and select one with a trit coincidence for Cinziana and Giovanna's empire waves? Well, certainly, we have a lot of reason. We don't even need the PEL exactly. We can use just the idea of quantum energy landscapes and classic energy landscapes as defining the peaks in the spectrum of probability amplitudes. Okay. Notice that if you calculate this for some particle at Sn, right, where n is our radii series, to ask your quantum field theory what the probability amplitude is for that particle, that position at that Sn, shell n, right, to be at some xyzt that you ask the probability theory about. So in order to ask that question in the first place of the formalism, you first must put input into the formalism and define your energy landscape, which is the sum of shells spanning some S at some radii n minus m and some other radii around S, the S which is your time 1 for your particle. So you're asking the formalism, well, what is the probability of these various coordinates at time 2, at S greater than the first S? And so you have to take this energy landscape, and you can't do it with one shell. Okay? Empire waves play out over n shells greater than 1. So anyway, so that's what this notation means. Some space where you cut off, in your computer at least, you cut off the physical universe in time. So you say, well, I'm not going to go backwards in time further than this or further forward because I can't compute that. And then you try to compute it and see if you get an approximation of physically realistic probability amplitudes with this formalism. This is a way to start proving or disproving whether this formalism is reasonable, right? So I'm pretty certain, I'm growing more certain that our space-time quantum energy landscape can be nicely modeled using tensor network formalism. So I'm learning more about it. The first principles of syntactical freedom in the QSN physical universe was discovered by Fong, and this is a shell in the action horizon model at Rn. Oh, I'm sorry, apologize. Yeah, these are repeated slides. All right, so this is a new slide. So respecting the geometric first principles of quasi crystal math, quantum gravity-based ZPF, right? Doesn't have to be the ZPF you're familiar with, but it's a sort of ZPF notion, right? This irreducible action and noise at the very fabric of space-time. where we can recognize that here we have connection quanta, which we called C yesterday. And we know that that C must be conserved over any quantity of ordered connection selections on the graph that simulates some small physical system or large physical system. And this is because the fundamental geometric stuff of a quasi-crystal is spatial curvature of the higher dimensional elements, it's specifically the root vectors of E8. And it is generally agreed that curvature of 3-space in a general relativistic view is conserved globally. For example, when we project a slice of the unit root vectors of the E8 lattice to 3 dimensions, using the sublattice angles as your angles which composite to your hypervector, which brings it to H3 symmetry. In this projection, you will get 8 magnitudes of transformation of your unit vectors from E8. 7 root vectors in 1D spatial contractions to finite length, all Dirichlet integer associated numbers. And then 1 root vector contraction to 0, a point. So when we project the unit edges of a slice of the Z5 tiling to the plane, we get a set of curvature expressions as 1 simplex contractions. So the 1 simplexes of the Z5 tiling are contracted, which is isomorphic to curvature. And then that gives you your 2-dimensional curvatures, your 3-dimensional curvatures, and if in the Elsner-Sloan, your 4-dimensional curvatures. So we proved that isomorphism of spatial contraction under projection, spatial curvature, gaps, and twists, as we use twists in the QSN to encode spatial curvature in that paper, encoding geometric frustration and in tetrahedral packings with those 5 ways. So the frequency of occurrence ratio of each contraction value of gravity, of curvature, is conserved in any ordered set of projections of 1 or more, which animate out to phazon quasi-particle animations. In other words, if you're going to use quasi-crystal graph drawing theory to do your quantum field theory, you're painting with gravity. You're painting with spatial curvature at the end of the day in a really mathematically reduced way. And if you think about it, what are fermions? In our model, there are these ideas like 57 groups, knot-like patterns that propagate in helical-like paths. What is it made of? Curvature, gravity. What are the photons made of? Curvature, gravity. What is the space made of? Curvature, gravity. What is an ordered set of frames made of that you call time? Gravity.
So these kind of contraction value can be an analogy of the vertex types in a way. It's a local configuration, right? So it's like it's like in quasi-crystal, the frequency of the vertex types are, always constant. And here you're doing the same.
Yeah.
So like you seems to talk more about the contraction of the edges, but also that's also kind of
and areas and volumes and hypervolumes.
Yeah. So if you look at the around each vertex, then it kind of like an isomorphism or like a equivalent in a way with the vertex types.
Yeah, I agree. I think that where you have a lot of contraction in the, let's for example take the 3D Penrose tiling. So you have in the 3D Penrose tiling vertices of different magnitude, right? And so Fong is saying perhaps you can link the magnitude of a vertex type to the magnitude of curvature. And she's right, in my opinion, because If you just visualize a 3D Penrose tiling and you study the vertex types, you see that in order to pack a lot of edges into one connection at a vertex, what do you have to do? You have to reduce the angle, okay? And that contracts the space. For example, if I have a unit square and I start reducing two of the angles here, like this, I can begin to contract the two space of the square down all the way to infinity at the line. And if you look at the 3D Penrose tiling, you'll see that there are two contractions of cubes, right? Because the Z5 tiling can be built entirely of cubes. And then as you project it, the cubes, all of them, become contracted spatially. And there are only two values in the Penrose tiling of contraction of the cube, the prolate and the oblate golden rhombohedra. So yeah, angle reduction is basically connected to the cube contraction or any n-dimensional polytopes spatial contraction. Therefore, the sum of all contraction equals spatial curvature is globally conserved by geometric first principles in quasi-crystalline quantum gravity approaches. In other words, if we were not privy ourselves here to some decent experimental evidence that curvature in the universe is conserved, right? So when Einstein was around, he didn't have access to that, to as good of data as we have. If we did not have access to that data, we would try to use that as a prediction to say that our model, by geometric first principles, requires and predicts that upon measurement we will find eventually that space curvature is conserved universally. But it's too late because I think they've got some evidence on that already. So accordingly, in the Penrose tiling, the average valence rank of 4 is globally conserved. So not only is the space conserved, to Fang's point, this defends her point, which is that, well, if you kind of think about the Z2 tiling, the checkerboard, you have an average valence rank of 4, because every valence is 4. And you have the same 4 in the Penrose tiling, where you have vertices of degree 7 all the way down to 3, and where the frequencies of each of those 7 are related as the power series of the golden ratio up to golden ratio to the power 5. And so they have very beautiful frequencies of occurrence, and globally in the Penrose tiling, the frequency of each unit of this curvature is conserved. So you always have that vertex, degree 7, it's always going to be globally in the same frequency no matter how you rearrange those vertices. So you're rearranging gravity, curvature, in these different patterns to simulate fermions and bosons in this view. And so there's a conservation of vertex types, conservation of edge length, frequencies and types. There's conservation of the two-dimensional and three-dimensional composites of those things. So it's kind of cool.
So then the curvature will be the difference between the actual valence of a vertex type and the 4, which is the average.
Yeah.
So if you have less, you have a negative curvature or
Yeah.
a positive curvature, and if you
Yeah.
have more, it's a negative curvature.
Right. And notice the relationship we're in the Z 5 lattice, you have an average valence rank that is some number, and 16.
Z5?
No, Z5, 16.
2 times 5 is 10, right?
Are you saying there's an average valence rank in the cubic 5-dimensional lattice of 10?
Right? It's positive, negative.
Okay, I don't remember what it is, but I'll go with Fang's. But the point is there's a nice ratio where the average valence rank there's a fraction, a nice integer fraction, rational fraction, right, of 4 over whatever.
10 to 4, that's 5 to 2, right?
Yeah.
5 to 2 projection.
Right. So it's kind of cool because the delta between 5 and 2 is 3, and we've reduced 3 dimensions, 3 spatial dimensions to go from Z5 to the plane, where we reduce dimensions by 3, and we get the delta between the 2 average valence ranks of 3.
So that's what the ratio is, the dimension ratio. The ratio of the average valence rank is the ratio of the dimension.
Right.
For Z lattices, if we consider Z lattice as like flat, basically zero curvature.
Right. So it's kind of pretty. You see pretty mathematics coming up in this kind of way of thinking. All right. So at a deep mathematical level, phazon quasi-particles, they're just coherent patterns of rearranging the various magnitudes of spatial curvature that you're given in your given quasi-crystals as your letters that you can rearrange according to rules of rearrangement and according to the syntactical freedom allowed within those rules. So then any set of orderings which forms a quasi-particle is analogous to creating coherent 24 frame per second animations with just 3 types of paint, let's say. Red, green, and blue pixels. Discretized, though, to where you can only use your paint on this grid, on this monitor. And but in our case, the paint colors are a very small set of spatial curvature values, where each global animation of paintings with curvature, gravity, which describe our particles and the space and time, it's all made of curvature paint, gravity paint. And that gravity paint is conserved both in terms of the quantity of curvature paint that you can use per frame universally, and the quantity of each color of each type, and the ratio that is of each type. So, and these conserved connection values, where the connections are curvature, are I strata of information. So if you want to paint a physical picture, whether noisy, containing no emergent information, or whether complex, containing lots of emergent information, you have to start with the units of curvature that's conserved. Like whatever you're given, that's what you can build.
That's the paint there. And the other side is that's a paint, and the other side is the picture that you want to paint. But the left side should be infinite. It shouldn't be like a finite. Right? So on the right, that's your paint.
Right.
That's the vertical space. That's a finite.
Right.
And then so you grab the paint, you paint the picture on the left side, which is you use the color like more evenly distributed, and it's an infinite space.
Right. Yeah. That's right. You did that the other day without even knowing how helpful it would be for today. All right. So according to the principle of efficient language, these quanta of I, which are now quanta of gravity, or curvature at least, they must self-organize as the frame count increases universally. In other words, let me try to rephrase this because this is a subtle point. The principle of efficient language implies that the universe will reduce its entropy, its noise, over time. And the reason for that is because of the strata. How far up, if you have a universe beginning at the Big Bang and going only 3 shells, and that's your universe, right? Well, how high up the strata can emergent information possibly go? Not as high up as if you had a very large number of shells, like 14 billion years divided by the Planck time. And so as the universe goes on, because the strata of each level of emergent information contains greater I, greater information because it contains greater E, the negentropic power of E to act as a force instructing the system how to self-organize becomes greater, and furthermore, because E is greater, deeper into space-time along the time axis, it's stronger than the past. So the future in this information increasing universe pulls the evolution of the present toward itself with a greater force, negentropic force, than the past pulls toward itself. And so this is why you have a direction in this formalism of time and of entropy and of information. There's a direction to the increase in magnitude of E in the universe, with I always conserved by geometric first principles, because I reduces to gravity, to curvature, to the letters, right? So, all right, look, and what I just said, it's more than just the PEL. In other words, I'm not saying that information in the universe increases because I like the principle of efficient language. You understand that you can have more. Okay, here's an analogy. With the number 100, you have an exponentially greater amount of set theoretic combinatorics in the number 100 than you have in the number 2, right? And similarly, in a strata of complex systems, you have an exponentially greater amount of combinatorial information than you can have in a much simpler and smaller quantity of strata. And because of this fact, this combinatorial mathematical fact, you wouldn't even have to subscribe to the principle of efficient language specifically to sort of deduce that if you're going to try to do a code theoretic view like we're doing, where codes always imply compound symbols, they always use compound symbols, that your information content of the universe will increase. Now, I think a lot of people would agree that the most complex system ever discovered in the universe, other than the universe itself, is human consciousness. It's barely understood. The deeper we go into neurobiology, the more we get surprising things, like what I told you yesterday about the recent mapping of brain signatures when you have a coherent thought to high-dimensional polytopes, and then it phase shifts down to some lower dimensional polytope, perhaps with a different thought. And so human consciousness is so vastly complex that we have not scratched the surface to understand it. It is creating one of the most amazing negentropic forces that we have ever seen scientifically, even greater than DNA, although it's built of DNA, right? You can't have your consciousness without DNA, it seems. And so it seems that at a very deep level, that if consciousness is allowed by physics, which it is, and if consciousness is a complex system, which it is, then there should be no arbitrary cutoff for other similar complex systems that are simply greater in magnitude than a human consciousness. And logically, the negentropic force of such a more complex consciousness than ours would instruct matter in the universe how to behave, including, acting as strange attractors. So, because DNA didn't have to create 4 letters that allow humans and this abstract consciousness. We have 10 million species on Earth today, and before us, in the rest of the 1/3 the age of the universe, there were another approximately 90 million species. And so this particular biosphere has cranked out 100 million different genetic codes, each a different species. And the biosphere is concerned not with consciousness. The biosphere, in evolutionary biology, is concerned with symbiosis or synergy between biological systems. And ultra-high consciousness tends to be non-symbiotic. Sharks, for example, have stopped evolving as quickly in a given environment in some temperature of ocean. They kind of have stopped. They're much more ancient because they are far more perfected. Compared to Homo sapiens, they have been adjusting themselves with random mutations for a longer period of time. And their consciousness doesn't need to be at our level. They need to be sleek, aerodynamically fluid through the water. They need to have, speed, big teeth, incredible sense of smell to sense a drop of blood from a mile away in the water, right? And they never harvest more fish than what they need. They never get out of balance symbiotically with the rest of the fish and smaller organisms. And so with symbiosis, okay, in biospheres, you have ever more increasingly complex strata of biological information, yes? So do humans with our ultra abstract consciousness. The first animal from this biosphere out of 100 million different iterations of the legal ordering of the 4-letter code of DNA, nothing has happened like this. An animal capable of abstract thinking to worry about the future. Will I send my daughter to college? Worrying about the past. Did I make a mistake on not reporting enough deductions on last year's taxes, and then create arcs, right, of story meaning between the past and future. This unique quality of abstract thinking to create links across time and ideas is what leads to our ability to create mathematics, right, and to discover the fabric of the workings of a mathematical universe. And it's not happened, okay, on this biosphere, in the fossil record at least. And so what's interesting is the question, why? Like, why did it happen? Why did it apparently happen once? If biospheres don't like this kind of anti-symbiosis, I mean, we really do have the power now to eradicate a large percentage of the 10 million species now. At one point, when I was growing up, we had 20,000 intercontinental ballistic warheads in the US pointed at every single ally that Russia had and every single metropolitan area of Russia. And they had an equal 20,000 warheads pointed at, some of them at us. We have 300 metropolitan areas in America. And that every one of those metropolitan areas had a very large multi-megaton warhead pointed at it, and every other ally we had, such that almost the whole world, every meaningful population center on the globe, with the push of one guy. It only took one, not two, because if he pushed it, the other guy would push it automatically. And so that's not so symbiotic, right? That seems not to obey the principle of efficient language, because then the biosphere, take the Serengeti. You have some event where a lion species in the Serengeti mutates, right? The 4-letter code adjusts itself by quantum tunneling, which is believed to be random. So this supposedly random mutation caused by a random quantum tunneling event alters this lion lion progenitor who can build a pride, alters the DNA such that the lion becomes grotesquely more intelligent than the other lions, 20% more intelligent in one mutation. And then he generates a pride, and that pride multiplies. And within a few seasons, what will occur, what is known in evolutionary biology, is because the lion dropped out of symbiosis and balance with the intelligence of the gazelles, that new breed of lions, maybe it's not a new species, but it's different. Its genetics are different. And it will so severely outsmart the gazelle population. Within a few seasons, the gazelle population will drop below reproductive threshold, thereby killing off the lions that have mutated and leaving the old lions that were only approximately as intelligent as, they were in symbiosis with the gazelles. So this is normally what has happened in the fossil record, where an animal in a predator-prey ecosystem getting too fast, living too long, getting too intelligent, anything that's out of balance with the symbiosis of the predator-prey network gets snuffed out. They snuff themselves out. So humans have been able to get away with murder. In other words, we did become grotesquely more intelligent in terms of abstract thinking. We almost got snuffed out. One almost snuffing out was the Cuban Missile Crisis, where 40,000 large nuclear warheads would have decimated the entire planet, bringing us to a Mad Max world for a few hundred years. And it didn't happen. And there were lots of other opportunities for it to happen, and it didn't happen. And so in order for the movie with Leonardo DiCaprio called Catch Me If You Can is really what humans are doing, because evolutionary biology abhors significant differentials in predator-prey systems of one animal's intelligence, speed, or any other factor that gives it advantages. And so it tends to harmonize, right, and balance things evolutionarily by distincting species. So it didn't happen, and in order to make sure it doesn't happen, we have to escape this biosphere. If you're interested in seeding any part of the rest of the cosmos, such as this solar system, with high consciousness that somehow one out of 100 million species emerged, if you're interested in that, the smartest thing to do would be to maybe send settlers out to Mars and develop hyperdrives to go to Alpha Centauri and see if there are interesting planets we can terraform there as our technology increases. But once that genie is out of the bottle and some animal that did Catch Me If You Can and got away with it and escaped the biosphere, it would be able, with sufficient technology, like a doubling algorithm, to permeate the rest of the universe, going out in anthropological time, not even, because doubling algorithms, not even geological time, and certainly not astrophysical time scales. So if the universe needs that, it would perhaps, as a strange attractor, pulled a mutation from the supposed randomness allowed by the tunneling, which generates the biodiversity and speciation on Earth. It would perhaps have allowed that about 1 million years ago, when Homo sapiens showed up on the planet. And it did. I mean, it did occur. It either occurred by freak coincidence, which is 1 out of 100 million, or it occurred by some strange attractor effect where high levels of emergent information forward in time, which is like our descendants, which speciate out from us and are extremely different, pull the probabilities. So it's the underlying code theoretic mathematical logic of this principle of efficient language, which states, as a quasi-crystallographic graph drawing-based quantum gravity code continues to self-organize to higher strata and higher interaction of combinatorics of strata, then the emergent information at ever-increasing, which is the emergent information, okay, which ever increases its complexity of strata, will begin in an exponential fashion to act back upon the evolution of the system itself, both forward and backward in the ordered evolutionary set with increasing magnitude of action, that is, the negentropic action, from higher strata, such that the evolution itself tends toward infinite complexity and information content.
So if I can just summarize your very good demonstration that we made. Was very living, but yes. I understand this as a demonstration, strong demonstration of this fact that the Earth, by programming the bioequilibrium such that if a very smart species emerge, this smart species will understand that the Earth will kill it, because the smart species itself will understand that it is out of the equilibrium.
Right.
Then this smart species will go out, spread into the space.
Right.
So this is demonstrating that the self-organization of the biological equilibrium of the Earth itself has the will to spread out in space.
Yeah. There's something called the Gaia hypothesis, which was by John Loveland, and he believes that the biosphere of Earth is an organism, a complex organism where you can generalize the definition of life to reasonably match up with his Gaia hypothesis. And so it's the idea that there's an emergent intelligence of some form. It's an emergent system, the entire biosphere, including the Earth itself, the weather, the atmospheres and everything else. And the thing is it's not virtually, it's non-computable. So one can surmise that ultra-high strata of emergent information can exist within the network of the biosphere, but one cannot compute it, right? So, yeah, thank you, Ray. So, no, this is not intended, what I said, the statement, that wasn't intended to be a statement of mathematical logic. It is a statement of fact, undergirded by the mathematical logic of how empires extend through space-time quasi-crystals, and how the sub-axioms underlying the code-theoretic axioms, such as the principle of efficient language, logically require self-organization via the mathematics of trit savings locking orientation. So remember, trit savings will not change the dipole orientation. So when you get an attraction, an acceleration which is an attraction event, you get vector minimization. You get dipole orientations, for example. And when you have repulsion, it goes the other way. And so in our eigenvalues, okay, where there's a trit savings, there's a reduction of entropy, the quantity of unique microstates, and it locks in, right? So that was something Amric was thinking about in a simple algorithm, to think about a locking principle. And I think about a locking principle probably different than Amric, but it's an idea that when there's a trit savings, okay, there's a higher probability of a second, third trit savings along that direction, or two things will orient themselves in the same direction in order to enjoy trit savings, because trit savings is nothing other than the lowest energy landscape for that particle locally.
Flowing downhill.
Right, and where you allow quantum energy landscapes, then you can have the notion of non-local lowest energy landscapes, such that you get these correlations that are basically also trit savings, but that they're extended across the space-time network. So there is more to it than just this, of course, in terms of first principles math. there's things like the logic of the shift vector codes that are correlated to the AB equals P probability amplitudes in the algebraic solution space. So, of course, modern science has no generally known way to conduct an experiment with observation from the future. Generally known, because I never want to say that there's, nobody knows how. So please don't be tempted to think of the limitation of the speed of light, and this is not for you guys, this might be for any people watching us. Quantum mechanics allows for interactions between objects instantly across time, right? This is experimentally demonstrated now with quantum entanglement, which has been demonstrated now across time, not just space. And until a quantum gravity theory is developed, the raw probability theory alone of just quantum mechanics is not strong enough, complete enough in some sense. I mean, it's pretty strong and complete as a probability theory, but it's not at all strong as a hidden variables probability theory. And so as we discussed yesterday, we all already knew that if there is a hidden variables theory that explains the quantum probabilities of the probability theory, it must be both non-local and non-deterministic. That is the set which was protected with Bell's theorem and Elaine Aspect's experiment. So today, physical experimenters are caught in the system at some local series of frames, like avatars in the simulation itself. They're in some sense observationally trapped using ordinary methods of observation locally. Therefore, we cannot easily study how future frames act upon past frames, but I think we can study it. And it is natural and common sense for humans trapped at some vantage point in the ordered set of QSN frames, which is time, to observe ordinary classic causality. Makes sense, you're here and you remember being here a moment ago. And so what you see is a relationship between a moment ago and now. You don't see the relationships exactly from the future, acting in a feedback loop with the present. So I don't blame people for that common sense. However, the concept can still be studied experimentally, and it has been. The class of study is chaos theory, where it has been observed that the future states of evolution, of potential evolution, of potential self-organization in a dynamic evolving fractal such as the Mandelbrot set or some other system, it acts backwards in time, as we discussed, to draw the evolution of the system toward itself. We don't yet understand the workings of this. We understand it's happening. It's the strange attractor. And it may be a deep mathematical principle of our formalism. In other words, we may take the inspiration of this idea called the strange attractor from chaos and fractal theory and retrofit it into some rigorous understanding of how empires running through time must, by geometric first principles, when you're using trit, savings, and cost to define your energy landscape and eigenvalues of the probability amplitudes. So that's one of my goals, is to rigorously, mathematically reduce that to first principles, that way of thinking. And it may not be a proper strange attractor. It just may be inspired by that concept. But it could also be deeply related to it. Because after all, nobody knows why, at a first principles level, the Mandelbrot set encodes exactly the golden ratio. Nobody knows. It's a mystery. And the reason it exactly encodes the golden ratio is because it exactly encodes the full and complete Fibonacci series And the full and complete Fibonacci series exactly terminates at the golden ratio. So this similarly, there's another thing that's not well understood besides strange attractors. And that was discovered by Eugene Wigner. And it's called the universality signature. And it's observed, completely not understood, a big, big mystery. It's a black box, right? And the reason it's a black box is because we cannot compute complex systems. We cannot use quantum mechanics to compute the probabilities of anything beyond a hydrogen atom, and there may be another simple atom that we've now gotten up to doing. But we really cannot compute, we're nowhere close to being able to compute using quantum mechanics a heavy atom, a more massive atom, and we certainly cannot compute constellations of atoms, even if we imagine vastly higher computational power. So then that's the space of NP problems, right? These problems that cannot be computed in a finite universe. And so that's just another way of explaining what I said. It's an NP problem. This universality signature, okay? The universality signature shows up in the discrete quasi-periodic spectrum of the distribution of non-trivial zeros in the Riemann zeta hypothesis. That is, they do a Fourier transform of the distribution of zeros, and they find that the pattern is both it's both aperiodic and highly ordered. And Freeman Dyson defined that as a quasi crystal. And we find the universality signature in that pattern in number theory, right? And then we find the universality signature in the spectral signature of the hydrogen atom. And we find the universality signature, again, the signature is a quasi crystal. We find this signature also in the very complex data set of the bus interactions in Sao Paulo, Brazil, where they collect huge data sets, and it's a complex system. The universality signature, this one-dimensional quasi-crystal, shows up again. And in fact, every single complex system that's ever been studied to look for the universality signature has resulted in finding this one-dimensional quasi-crystal, the universality signature. So again, there's a limit with complex systems in understanding. There's a limit, even though you can do 100 billion floating point operations to generate some complex dynamical fractal. It doesn't mean that just because you can do those computations, you can backtrack and understand the fantastic combinatorial possibilities that might be hiding within the mathematics of that network of floating point operations. So in these cases, as with all complex systems, and how Heisenberg showed us that complex systems can act negentropically as a force in obstructing matter, these things act as strange attractors, pulling the evolution of a chaotic system towards some future state, without that pulling being able so far to be explained by the forward in time causal actions themselves. So according to observation, the complexity of order, that is the rank of E and total I in the universe, must increase over time. You guys know this, but we see this happening as we go from a quark gluon plasma to a hydrogen universe, to a universe with 81 stable elements, to a universe with biospheres and DNA and technospheres and on, and consciousnesses. So there is no evidence that negentropic forces conserve entropy globally, by trading entropy in one volume of the universe for negative entropy in a different volume. It's an idea. It was popular 150 years ago, as it is today, to use the naive special case of repelling charges in, say, like a helium gas in two temperatures separated by a separator inside of a box, a completely closed box where no energy can escape and where no energy can get in. And when we remove the barrier, the repelling charges seek to get as far away from one another as possible. That is, they do not self-organize into a hierarchical strata of emergent information where the emergent information acts back upon the evolution. That's not what happens.
But it's not the FCC lattice.
Thank you. It is not the FCC lattice.
You have a rotational symmetry because it goes to the equilibrium when you open.
Absolutely. Yeah, we talked about that, but I didn't change the slide. So interestingly, the reason this is naive, in my opinion, is because it's not naive because it's not physically realistic to close a system. Like you can't do a closed system. That's not why it's naive. To me, that's fine because I don't mind dealing with approximations experimentally to get kind of good information about how nature works, right? Einstein felt that thought experiments are useful even when not physically possible. The idea of an electron at rest, for example, is not really physically realistic, but the thought experiment is very helpful because it helps you understand the limit, right, of what there's a limit at the speed of light and completely at rest, where there's this inverse proportionality of mass and experience of time under special relativity for this particle. And so the electron at rest as a thought experiment is helpful. So a lot of what I'm suggesting are thought experiments of limits, which are helpful. So in a similar way, the following thought experiment is instructive. Consider a closed system around the Earth. It's abstract. You can't do it. It's closed. So it can be a Faraday cage, or it can be a mirrored sphere, or it doesn't have to be anything other than just a mathematical idea of just absolutely closed. No energy can leave, no energy can come in. All right, so it traps all the energy in Earth. All the entropy created on Earth from, say, heat engines would radiate to the reflective boundary in this thought experiment and then radiate back into the system. Strata 1 information cannot be created or destroyed. Now, what must occur in this thought experiment? You cannot be too aggressive and claim that if photosynthesis from sunlight stops, the biosphere and continuing self-organization of technology and species quantity increase, all of that emergence must stop evolving to higher and higher strata of complexity. Life doesn't need the sun, it just needs energy. For example, there is thriving life 5 miles under the Arctic ice with no sun energy, and there's life 5 miles below the ocean surface, which is fed by geothermal energy. And there is a lot of energy in every atom. Recently, NASA, a month ago, filed a patent on cold fusion. And I have a patent I recently filed on cold fusion. A few years ago, Mitsubishi filed a patent on cold fusion. In fact, we're now up to 2,000 peer-reviewed studies showing cold fusion is an established anomaly in physics. Established here means established in the minds of the thousands of scientists who have kept up with the literature on low-energy nuclear reactions since a bit of confusion in 1989 occurred with the reporting of Pons and Fleischmann's experiments. Anybody who looks at the literature will say, okay, I didn't know it was an established anomaly. I'll add that to the list of the other hundreds of established anomalies that currently exist in all realms of physics. So we can generate electricity from many other sources other than the sun, cold fusion being just one of them. So it's known that photons can be reorganized into fermions. So we can continue rearranging and exchanging free and bound energy as long as the system is closed and we can re-harvest the energy. But we need science and knowledge and strategy in order to do that. We probably need some new quantum gravity theory to really be able to do that. The rearrangement and interconversion of photonic energy, gravitational energy, and mass energy is a matter of strategy and knowledge, which uniquely comes from ultra-high complex systems, such as humans, on the emergent hierarchy of information in the E regime. So what is needed to maintain this ever-increasing self-organization and growing magnitude of non-conserved E in such a closed, off-equilibrium thermodynamic system in this thought experiment is one thing: information. For example, scientific knowledge in the form of emergent intelligence of the biological and synthetic complex systems that can emerge, that are allowed to emerge. If it is simply unfounded in experimental fact to say that because a closed box of repelling charges will evenly distribute its energy over time, that a system, or heat over time, that a system of aperiodically ordered ratios of various attractive and repelling van der Waals forces in strategic ratios and angles, gravity, strong quantum correlations, and ultra-high negentropic strata of information acting as a force will also self-organize the system into the most homogeneous microscopic distribution of heat. Of course, the second law bluntly states this without consideration of any of these forces, not gravity, not any of the other ones, certainly not negentropy. And it deals in the special cases of repelling charges or the wrong ratios of locally configured atoms. Boltzmann is fine. He wasn't trying to do all that. He was trying to deal with heat engines. And he didn't know about quantum mechanics. It was 1850 or something like that. And he didn't know about DNA and Heisenberg's idea of negentropy. He knew about gravity, he knew about Newton's gravity, but I agree with him. It's a little bit trivial in a closed box of gas, so don't worry about it. But it's not trivial at larger scales, where we see self-organization occurring all around the universe due to gravity, such as quarks and gluons organizing into 81 stable elements. That's all due to gravity. So I suppose, so I have already given the example of a quasi crystal yesterday self-organizing under a certain pattern of annealing or energy dissipation, which is a completely different thought experiment than the closed system, because this is a system, as Marcelo said, in a heat bath where the energy dissipates and yet does not evenly distribute the energy or heat in the most microscopically homogeneous way possible, which is at the near neighbor distances of the FCC arrangement. Under the power of deductive reasoning via the lens of the code theoretic axiom, the principle of efficient language demands that the first law of thermodynamics is still a law. And it clarifies that the second law never was a law in the first place. It was a conjecture derived from an overly simplified special case of repelling charges, that is, non-trit savings. Trit savings and non-trit savings are not just a trivial binary opposite of one another. They are completely different code theoretically in what they do. The universe likes trit savings. It doesn't really like trit cost. So this is getting deeper towards the end, and this is called dipping our legs further into emergence theory physics. In this section, we'll get into even more rigor, where it's now, in my mind, this is a little bit more than a toy model, and it's certainly not a rigorous formalism in any way yet. But in the first half of 2018, I want to take a bit of a quantum leap forward and enter the realm of algebraic abstraction in terms of making all of our geometric visualizations and my discussions testing it, making it rigorous, like beginning to do physics. So, a system with high E is a system with less destructive interference. Okay, I'm going to be using these words analogously because the idea of empire waves, where two empire waves can have a relationship involving a lot of trit repulsion, trit anti-coincidence, trit cost, that can be thought of as a sort of destructive interference, right? And the other can be thought of as constructive. And the waves, as we talked about earlier, they overlap. All the empire waves are overlapping. And so anyway, this leads to a length value as follows. Nature expresses as particle clock cycles and forward propagation steps if it's a fermion. It expresses both of those two components that are inversely proportional with the same brush stroke of gravity, which we can think of as the Planck length. And if you've not carefully understood the paper that Marcelo and I did, and Ray and Fong, we wrote that paper that got published in the Minkowski book, and we have this understanding of how the logical Planck length is really a golden ratio value, and we argue that pretty well, I think. And so it expresses this with the brushstrokes of length and a value called connection, which is we defined as the symbol C, where D is high, right, which was the density connection. So is the sum of lengths of all LP expressing propagation and clock cycles. But remember, D was used to explore a whole infinity of quasi-lattices and lattices to discuss, the density of encoding in a graph drawing. So a 57-group massive particle in the QSN expresses its total lengths, units of curvature, as an inversely proportional ratio of units of LP used equals C, connections, used for clock cycles, T, to forward propagation units, P. For n units of length C over m frames, this massive particle cannot exceed a ratio of T over P, which is greater than the bound of Tp equals 0 over P, and on the other side of the bound, T equals 0, T is 0 and P is 1. So here, in this case, right, connections would equal P. That, in other words, the total units of connections as an integer quantity of the Planck length, as an expression of curvature, will be expressed as propagation, and none will be expressed in that limit as particle clock cycles. That is, the electron going at the speed of light experiences no clock cycles because it used all of its length, all of its connections for propagation. So there would be a required, in our formalism, we would predict, if it wasn't already known, we would still predict that there should be a speed limit for massive particles, which is inversely proportional to a required time experience limit of T to P equaling T0 equals T for the 57 group at rest, right? Just cycling in some coordinate in the QSN in this Hamiltonian circuit without propagating in the QSN. Where n units of connections of LP, there will be the time limit where the electron can experience no greater quantity of Hamiltonian circuits as clock ticks or cycles over n frames, a limit, where n is the number of frames or graph drawing state selections on the QSN, and where the local element or a difference between two steps in a quasi-particle are 1 unit of C equals LP, such that n is an integer multiple of LP as L, just total length, and where trit coincidence equals trit savings occurs once or more during a sequence. In that case, then L is less than T plus P. So this is a really important concept. This is saying that just as the case where when you have a trit savings, remember I said if I have a dot moving across the screen in 1-inch increments, and I play that for you, you'll view that as going at some rate, right? But if I remove one of my frames, or 10 of my frames, then you will interpret that as the dot accelerating it in something. It'll go like this, and then just jump like this, right? So that's an acceleration due to trit savings, okay? Where I drew you the letter, the way to kind of memorize the idea of trit savings as the letters where they're shared, a savings of a letter. Okay, but it's the opposite that happens when, so you have some L expressed, right? So there's some L expressed here for some number of frames, time, but we removed frames, and even over a smaller number of frames, the pattern still advanced. So if you advance the same distance in less time, that can be interpreted as an acceleration, something moving faster overall. Okay, conversely, if you have a trit anti-coincidence or a trit cost, it goes the other way, such that total length is less than the sum of the units used to build it, which is T plus P, because some of your units of connection used for clock cycles and propagation have been enjoyed by you by another empire wave. So you've achieved a particle coordinate without having to have your own frame, your own shell, your own action. It wasn't your action, it was part of another empire field, and you advanced. Okay. So when L is less than T plus P, it's called attraction, acceleration. And where there is trit conflict, which equals trit cost, once or more during a sequence of this quasi-particle's action, L would be less than the sum of the connections used for T plus P.
Greater, you said less.
Yeah, thanks, Fang. Be greater, okay? We can develop this all a lot later, maybe this, but this is an absolutely core ground of this toy model, and we have to find out why it's wrong, right? So we're gonna have to really grasp it, then find the deal killers. This is called repulsion. Where no trit cost or no trit savings occurs over n frames, L is equal to the connections that sum to T plus P. And this is null interaction. In Boltzmann's entropy, we can see that over some duration with n particles, the quantity of microstates is defined by the frequency of particle collisions. Specifically, the total quantity of vectors over some time is high when collisions are high, and the length of the vectors shrinks as collision frequency increases. In emergence theory, we probe deep into the first principles of what a collision is in the first place. And a collision is where L is less than T plus P. So we see that L, T, and P are integer multiples of the Planck length. So quantum field theory has a notion similar to my L here, It's called 0-point energy. So I'm going to reduce all forms of energy to be different manifestations of your conserved C, which is your conserved I, analogous to 0-point energy. And I'm going to reduce L to precisely a Planck scale graph connection mapping a particle in one frame of the QSN to a second frame in an ordered set of frames. One may map the two frames to one another by the same Planck unit of distance in the Elser-Sloan quasi-crystal. So I'm going to use capital C to denote the quantum of this foundational action, which is a connection, and energy, because it's a connection. All right, again. And its form is length, integer. The connection can be any integer multiple. So the connection. Now I'm moving from connections. So at the graph, under it all, you can have connections at the Planck length. But we're going to generalize connections and use the idea of connections in a discretized space-time view, where we have a particle in our quasi-particle animation at x, y, z, t. And then it's gone, and we have a particle at a different x, y, z, t 2. Okay? The distance between the two must be an integer multiple of the irreducible length, right? But the connection is still now a C. So I'm saying that a C, a connection, does not have to be the Planck length at the foundational graph connection space, because I'm going to try to get into the scaling factor, which changes the cut window in the higher dimensional space, the cut window thickness. So we can change from our symbol L to this new symbol C, where C can be an L of the golden ratio, which is along the golden ratio power series. So normally, when we think about the entropic spectrum, we see that when E is high, which is reduced here to C, connections, collisions are high. And so W is high in Boltzmann's formalism. And when we lower C, things settle down to having eventually no collisions. So we lower the quantity of energy to this idea of absolute 0 Kelvin. So it's helpful to focus on how when there are collisions, L is greater than the sum of T and P. In other words, length goes to waste. If you consider that nature seeks to maximize particle propagation and clock cycles, translation and rotation for a given set of graph actions or classic energy, right? If it goes to waste, you waste the opportunity to get more rotations and translations, which define your clock cycles and your forward propagation when you have trit cost instead of trit savings. So we don't consider particle clock times in Boltzmann's entropy, of course. So we can ignore T and see that when entropy is high at a given C, P is less than C. Propagation is less than C. And when entropy is low, at the same C, P is greater than C. The propagation distance can be greater than the quantity of connections. So it's helpful to focus on how when there are collisions, All right, and when entropy is low, at that same C, P is greater than C. All right, so the radical idea here in this new first principles approach is connection, the connection to a savings of a unit of what you're working with. We can recast this connection savings into 2D and 3D connection groups and have the same form. In emergence theory, we use connected groups of 4 points. So they always come in equidistant groups of 4. The regular tetrahedron as our basic trinary unit where it can be on, right, left, or off. And this reduces down to the same basic form using 1D that I'm trying to share here in the following slides. So of course, we already know that Boltzmann's thermodynamics are partially incorrect in the sense that, in the same kind of sense that Newton's gravity is partially incorrect and superseded by the more precise general relativity. So too, Boltzmann's thermodynamics is not really what we're worried about. You know, I'm merely making analogies. And we know that some first principles-based precise quantum gravitational and code-theoretic quantum thermodynamics, gravity and particle physics theory is going to someday replace both general relativity and quantum mechanics. And of course, those were already replacing Boltzmann's thermodynamics. But quantum mechanics is not code-theoretic yet, where information and emergence is a core focus. Quantum mechanics has one foot in the old world of smooth space-time, where there is some probability for a particle at time 2 to be at any coordinate in smooth space-time, in infinity. And that's not code-theoretic. Code theory requires restriction, finite set of symbols, and generally as finite as you can get away with. And it has its other foot in the powerful notions that we appreciate from quantum mechanics about discretization. It's just that they haven't taken those notions yet to space and time because no one's figured out how. And that's why we might be very lucky here at QGR. We just stumbled upon the fact that a quasi crystal by mathematical first principles is a non-local topological net. And so emergence theory is still in its very early stages, where I am attempting to articulate the underlying first principles algebra, code theory, and geometry so that as a group, as an organism, we can be more powerful than the sum of our parts. And we can do it, we can build it. So a tetrahedron on the QSN is a trit because it has the 3 aforementioned states that can be selected during some frame. Quasi-particles are any emergent pattern that propagates, such as a water wave emerging from H2O molecules, a soliton, a quantum dot, a photon, and on and on. There's so many quasi-particles. So quasi-particles that emerge in an animation of 2 or more state selections on a quasi-crystalline possibility space of points, as I said, are deeply non-local because of the empires. So we call the dynamical version of an empire the empire wave. It is very different than a single frame with an empire, which has a cylindrical volume radiating out. For example, a 20 group where there is a higher density of trits than in other radial cylindrical volumes. So in a single frozen frame, only part of the physical picture can be understood. But in ordered sets of 2 or more coherently related frames on the QSN, driven by the probabilities in the space of ABP solutions, a form of discrete calculus comes into play. So the left image is analogous to an empire, and the right image is analogous to a sequence of 2 or more empires forming an animation. The reason, I'm mindful of the time, probably just because there's one slide I want to show you. The reason the empires are wave-like over 2 or more frames is because massive quasi-particles, such as 57 groups in the QSN, move in 2 wave-like patterns. They have a stepwise spherical motion as a Hamiltonian circuit describing their individual clock cycles, which defines the t part of this TP ratio. And they propagate forward along helical paths defining the p part of the ratio of the finite set of inversely proportional t-p integer ratios that range from t0 to t to 0p over some integer quantity of frames or connections, trit selection states, or binary point registrations, or edge connections, or tensor network p solutions, etc. And I'm not going to play that. So this is the finite range discretizing the infinite and inversely proportional general relativistic spectrum of ratios from the electron at the speed of light to the electron at rest, an infinite smooth spectrum. So now, try to visualize the empire wave of an electron at rest in the QSN as looking kind of like this, with only empire waves spraying out, right, as the water. And in this discretized calculus, essentially encoding the meaning of these waveforms rotating, discretely rotating out from this stepwise spherical rotation of this electron clock built out of graph connections. So, and note that this image isn't good enough. This pattern is rotating in a circle, not in a stepwise spherical pattern. So now imagine a more complex version of this in a stepwise spherical rotation from a water sprinkler. That kind of looks like this, right? But in 3D. Like just spinning out the empire field generated by this one particle. Now, take this dynamic empire wave in 3 space in the QSN, constantly rotating in a Hamiltonian circuit so that these arcs are changing position. And imagine what it would look like as the helical component of the empire from the forward propagation of the 57 group combines with this pattern. Now that sprays out into an empire wave. It's very complicated. It's not easy to visualize. And I cannot make an image for you to visualize it, but I can tell you that as I try to close my eyes, which I constantly visualize, that the closest picture I've found on Google is like this. It has a dipole. Essentially, it has a direction. You know, it's something like this. But we have to model it. We don't want to just speculate. We want to get it into the QSN, understand what these empire waves look like, and then start modeling it, right? Start computing it in some, I don't know if mathematical will be the choice, but we got to do it. And then these waves, which go out all the way to the end of the universe, and they drop in density with distance in terms of the important parts of these waves, they're everywhere. So the entire energy spectrum of the universe, the energy landscape of the energy in this room, is the superposition of all of these waves which reach through time, right? Because the empires run through the shells. They run through. So that's the end, but that's the end of the talk today, and then we'll complete it after the holiday. But yeah, so I'm kind of excited about this, the algebra of this full space, and how that might imply a Hamiltonian later, and how that's going to tie in to connecting the energy landscape of the spin network of the QSN up to the tensor network space using matrix algebra, which brings us up to the relationship between E8 and its subalgebra, and the E8 lattice and its sublattice. So, thank you.